Alrighty, folks, today we are talking about the super keyword. So we have already used super in our subclasses. If you go back to a few classes ago, we discussed using the super keyword to call our constructors from our subclasses. So we wanted to call our superclasses constructor, so we used that super with those parentheses, passing parameters to the super constructor. Today, we're going to talk about some other ways that we can use this super keyword rather than just calling our constructors. So some background information. The super keyword is very, very similar to the this keyword that we talked about a while ago. So this is referring to the current object that we're acting upon. Super is going to refer to the current object's linked superclass object. So the object that for our superclass that is kind of tied to our current subclass object. So when we're building methods within our subclasses, we can use the super keyword to reference any public methods that we want to from our superclass. So let's say we have two classes, animal and dog. Well, we have our animal class, which has a type and a sound, both are a string. Our animal constructor takes both of those values as parameters, initializes our instance variables, and we have a void method, speak, where we get an int parameter, and we say, or we print this.sound number of times. We'll print that value that many times. Our dog class extends animal. We don't have any special instance variables within our dog class, so we don't need to take any parameters for our constructor. We're just going to pass dog as our type and bark as our sound. And our bark method within dog, we're getting a number, and we're going to call super.speak some number of times. So if we look for our instances of the super and this keywords, we've noticed that super is really only occurring over in our subclass, which makes sense. We're not extending anything with animal, so there's nothing to call super on. And this currently is only appearing in our animal class because dog doesn't have any instance variables to reference. So our super constructor call is referencing the animal's constructor, and our super.speak is obviously referencing animal's speak method. So if I were to say dog.bark, it would call super.speak. We can also say we could also just say dog.speak, and it would call this speak method as well, because it's inherited by the dog class. So we could either use bark or speak to accomplish the same goal here. Let's look at a different example. We have pie and apple pie. In our pie class, we have a type and a number of slices. We have our constructor to initialize those things. We have a method to return the number of slices, and we have a method to eat a slice, where we subtract one from its value. And then we have our apple pie extending our pie class. Our apple pie constructor takes a number of slices and calls the superclass constructor, saying the type is apple, and we pass that number of slices back through. Went to the next line again. So our Boolean has slice method. We're returning super.getSlices greater than 0, saying whether or not, yes or no, does my pie have more than 0 slices? And then we're overriding our eatSlice method. So within my apple pie, if I call eatSlice, we're going to call this method rather than our superclass's eatSlice. And so if this dot has slice, if we have a slice to eat, then we can call super.eatSlice. So we see once again, we have our supers on the right in our class that is extending another class. And we have this in a variety of different places, because here I'm calling this object has slice. this here isn't strictly necessary because it's just referencing a method from within the same class, but it adds a little bit of extra clarity. So it's good to include. So my super in my apple pie constructor obviously is referencing my pie constructor. My super.getSlices, we're calling getSlices from the pie class. This .hasSlice, we're referencing our own internal hasSlice method. And super.eSlice, once again referencing that outside one. So when we have this kind of class hierarchy, we're sending multiple times. We have person to student to high school student. Remember, I've talked about this before, but we can only use super to reach each subclass's superclass. You can't chain supers, you can't stack supers to move up multiple steps at the same time. So if there was something in person that I wanted to access from high school student, there were a method that was specifically from person, I would need to say from my student class, I would need to reference that method, and then I would need to reference that method in student from my high school student. We can only go up one step at a time. Now, if you remember, all public methods from our superclass are inherited into our subclasses. So if a method isn't overridden, we can kind of just call it from our subclass. It's still best practice to use that super keyword because it adds that clarity, saying we're definitely calling this method from our superclass, but it's not strictly necessary. And I'll show you some examples in the next slide. When we do have an override though, the only way to access the superclass's version of that method from the subclass is with that super keyword. So if we look at the pie example again, my hasSlice method, I was returning super.getSlices greater than 0. So since I'm not overriding getSlices in my apple pie class, I can change that super to be a this. The apple pie class is inheriting the getSlices method. It can use it by itself. We actually don't even need the this. We can just call getSlices, and that's going to call our superclasses getSlices because we don't have a local version of it. We're not overwriting it. So Java is going to check within the superclass. So this works, but once again, super is not it's not necessary, but it helps add clarity. So I'm going to recommend that we include it whenever we need to. Now, down in my eatSlice method, we are doing an override here. So if I didn't have this super.eatSlice, if I just said this.eatSlice or just eatSlice, Java is going to see our more local eatSlice. It's going to call itself over and over and over again, essentially forming an infinite loop, which we want to avoid. We do not want a method calling itself forever and ever. So here we need that super so that we're showing we're definitely referencing this eatSlice method rather than trying to call our local one over and over. So including that super also kind of protects us if we later down the line happen to override a method, or if we change the name of a method to be an override or something, then using that super ensures that we're not going to have any of these infinite errors. So that is how we can use super. Very briefly, we'll recap here. Our super keyword can be used to call a superclass's constructors and methods. And this super keyword is especially useful when we're performing method overrides because it allows us to still have access to that superclass's version of the method. And there we go. There is our lesson for the day.